Uh, Bismillahirrahmanirrahim. Okay, so we saw designing, software designing. Now we will see software implementation, means how we can develop a software. We start with the designing, and second phase is developing the software. I mean, designing is not the first thing. Means if we see the problem, I mean, if we have to develop something, then first we see the problem, understand the domain, collect the requirement, and write the specification. Then we start the designing. But anyway, we start discussion with the design. So everything what we start, so that propagates. So if I start with design, then whatever we have taught, that will propagate to implementation, developing, testing, and maintenance of the product. So that would, whatever concept we have talked about, layered approach, and then internal, external, or intrinsic, extrinsic component, and then we talked about, that is flyweight design pattern. Then we talked about abstraction in sending the signal across the layers. So that comes under builder design pattern. So this is what we saw. So now when we talk about the implementation, so implementation, what, like we saw that every layer is kind of, it is guided by, controlled by, hinted by upper layer through signaling, and that is an extrinsic parameter in the flyweight design pattern. And then the signal, what the signal comes. So upper layer is not supposed to transfer data. They are supposed to pass the signal. And when they pass the signal, that is through builder design pattern. Means it should be in layers of abstraction, and every kind of layer in the designing, once they receive the abstract hint, it is up to them how they implement. Like nervous system, they heal themselves differently than muscular system, but from outside the instruction comes as healing only because they see the problem in it. Okay, so and upper layer should be able to kind of hint or address each and every single entity down the layer. So not only body, if my hand is one subsystem, one module, then my mind will say to hand, then hand will say to this part, then this part, as it is. So it should not be like that. So upper layer should be, through some way, they should be able to tackle the lower entity. So that is a good concept. The other thing what we talked about the designing is each part, each abstraction, or the concrete layer, like bones, or then we start with the abstraction. So each abstraction should be reusable. So they should behave like a independent component. Up to here, we know, means they should follow open close principle, and means whatever the software unit we are writing, the unit of execution generally we say. So they should be kind of open close principle. That is one of the most important designing principle, where when we finish a module, then it should become a rock and it should not be modifiable. If we want modification, then we have to derive from it or whatsoever, but we cannot modify it. So means we can follow all the concepts, and so the granularity, the modularity, reusability. So these are the concepts till now. Now when in the I would say inception of, because anyway artificial intelligence is quite old, but recently there is a rebirth, inception. So the inception of the artificial intelligence, now it is concerned that modules should not be, modules should be reusable highly, but it should be active. That's why it should be intelligent. A module should be intelligent, not only reusable. I mean, it's not like potato sack or some other sack, then it is reusable. It should think on its own. So, means if I fit a module, if I know a module, if I know module that does this task, if I fit into it in my work, to start working. Okay, to start communicating with other areas. So that is the concept we talked about. Now, when we come to implementation, then how we will implement? We gave all the theory that layer approach and all modules should be very active. They should behave like intelligent, and there is extrinsic instruction. Upper layer should control the lower layer through extrinsic signaling. But how we would implement? Okay, so we'll go with the Python. Means Python is the most developed programming language. And there are many execution unit in Python, unit of code in Python. It starts from package or module, we can say package or module. Packages are directories, whereas modules are files. But again, a package can contain sub-packages and module. But package is executable, means it has program like it, execution unit. It has a code block. Code block means the way we write code in a function, we can write code in a directory, means in the init file, underscore init file. We can write a full-fledged program. And then inside the module also we can write full-fledged program. Then comes class level. Then also we can write full-fledged program. Class is not, class is a data storage and some data can behave like a method. This is C++. But in Python, Python class itself is the execution unit. Means it can execute. Okay. Then we have function. So function is supposed to be the lowest most execution unit. And then we can have like control statements like for while, and then we have exception like try catch. These are also control. These are also execution unit. And then with state. So that is context managers. So they also behave like, but there can be others also. Okay, and then in the function we can have generator comprehension, and then async, and so there can be other type of function itself. Okay, then we have objects. Class has object. Class has parent. Class has its own base class as meta class. So there are so many execution units in Python. So Python code executes wherever it is. Now, when we talk about the component development, either it is a function, control statement, class, or module or package. Now, I have started implementing. So, when we talk about the layers, what we talk in the abstraction layer, that is one implementation. Other implementation is at each layer in the designing. We can have a package to function, means we have package, we have modules, we have class, and we have functions at each layer also. And now, how I can write a granular code, how I can write a code that is reusable, how I can write a code that can be fit into anywhere. It should be active, it should be intelligent. That is a new challenge. Okay, now let's say I talk about any layer. If I have a class, then class can receive arguments. Means if I define a class, I can place arguments, or I can place arguments for the class objects also its init. Or a module can have argument. I can force arguments from outside. Means may not be at the time when a module get imported, but still we can force. We can set, or package we can set. Okay, function or we can anyway, means it's known that we can have a function argument. So wherever we are sitting, suppose we are sitting at function level, means it is easy for people. Now when I am sitting at function level, now there are extrinsic and intrinsic components. That is the biggest thing that we need to identify. So extrinsic component can be what we receive through a function parameter as an argument, or global variable, module variable, class variable, or non-local variable. Please be slow on the extrinsic variable. It is not a good design to pass so many extremes. It is something like, means be local. Okay, so if I am sitting in a room and I am sitting with two person and I am discussing, and there are 50 doors and 50 people are making sound, and anyone is coming and talking to us and going, then what we will discuss? Not possible. Means if I am sitting in a room, then I expect that no one would come. If something signal I receive, that should be minimal. So this is how I can develop something. So if I am developing at any level, if I am developing a function, the outside disturbance, I would say, should be minimal. 90% of the logic, 97% of the code should be internal. 10% maximum we can afford. Means it should be minimal. So global parameter, we call it module level parameter or non-local parameter, means it should be 0. Means that is the better. But anyway, we have a lot of noise, means a class level parameter, then object level parameter. Anyway, those are there. Plus, then extrinsic variable what we receive from the function parameter. So those things are anyway there. But try to code in a way that they should become like a signaling, means like a hint only. Each function should do a unit of task and it should really do without much interference. So this way, if we develop, then it is really not only reusable, function is becoming intelligent because it is intelligent, right? It is independent. What is intelligent? I am intelligent because I am independent. If I start becoming dependent on something, I am not intelligent, even though I carry a lot of resources. But it's not intelligence, right? It means intelligence when you do on your own. So that is intelligence. So if a function is writing a logic on its own with minimum hint from outside, then that is independent. Now function is ready to be fit anywhere and it will start behaving intelligently. Okay. Now the question arises that if I am a re-entrant function is there, if I re-enter the function or thread say whatsoever, Python is a different kind of. It's not a C++. Python is a data structure based programming. C++ is an interface based programming. That era is. I mean, I'm not saying Python is not interface based programming language. I mean, C++ integer pointer is separate, float pointer is separate, or class pointer is separate. To group few pointers, there is interfaces, and through base interface you can take the derived class. So that comes as polymorphic. So C++ is interface based programming. Interface based programming, I am saying that is the maximum. Or you can do reinterpret cast or a kind of dynamic cast, a static cast, and then you have to maintain a vtable which will internally work on these type of cast. Python is everything is polymorphic in a sense that there is a base class of the Python that is object, and everything is object pointer. Means reinterpreted cast, dynamic cast, static cast, all happens internally. So anyway, it is a interface based programming. Anyway, whatever is there in design patterns and anyway it starts from there. And beyond that, it is a data structure based language. Means in C++, if you have a base class, if you have a instantiation of a derived class, inside that you have a base class also. You can take out the base class. And then you can call base class method separately where this pointer will be from base. There is nothing like that in Python. So Python is purely data structure based language. So everything is a data structure. Once you get hold of a data structure, that's it. There is nothing hidden there. So if you hold a data structure of an object, that's it. There is no base class part of it. There is no data structure hidden inside. Base class part of the whatever object has attributes that we can stick to it. So it's like a banana trunk, and then we stick the attributes into that. So down is the derived class attribute and top is the base class attribute that we can stick. But the trunk is only one. But in C++, if you see the derived classes, there are many trunks. You have to get one trunk from that through dynamic cast and those kind of things. So Python is explicit language. Everything is outside. There is nothing hidden. Okay, so if you want base class constructor to be called, you have to call yourself. There is nothing implicitly will get called or whatsoever. If you do assignment, then its reference count will grow and its finalizer will call whenever. There is nothing hidden. It's a pure explicit language. Now when we are writing code with a function and I am worrying about that and I want to make the function intelligent, then how I can remember the states? Since function is a data structure, we can stick to the data. So once we make it re-entrant, it will be remembered. No need to go for static class, nothing is required. Whatever is there, it is independent at that level. If it is module, it is independent at that level. If it is package, it is independent at that level. If it is a class, it is independent at that level. And if it is a function, it is independent at that level. What's more? This is how we can start writing the code. Means first we decide, we talked about like mind, brain is the topmost layer, and then we have so many systems, hand system, and then this system, okay, I believe it is called Udan, and down is Apan. So, okay, so I believe this is called in Sanskrit, Udan, and so, and this is hand, and then we have respiratory system, skeleton system, anyway. So we talked that the upper layer, they come down and the way they use the, I would say they serve the lower level. So that is one thing. And each level, it is controlled through a Flyweight design pattern, and signal is passed through builder design pattern. Now at each layer, we again have execution units, blocks, and those executions. So when I am writing code for a particular layer like respiratory system, then inside that we will land up in many execution units, package level, this level, that. And then we need to use a libraries and those whatever. So when we write any layer, means there can be 10 package and 50 classes and 20 modules and like that. But we have to first understand where we are. If we are function layer or class layer, then when we think that what we can entertain from the upper layer and what we can let lower layer entertain through us, and then what we can do at ourselves. So if this function mentality is clear, then we can think about intelligent, reusable, fittable modules. That's it. So development is nothing but you understand the execution unit, its role and responsibility, become less dependent on external world, and you do something. Means you should be identifiable. So if I write 20 classes and 50 functions, then all 20 classes and 60 functions should be able in a position to fit anyway. So that is the development phase. We can start developing.